Hi everybody, welcome to this video on probability trees. Probability trees are a great way to visualize the joint events. That is, those events that are combinations of two or more events. Now, we are going to show you examples, but just to give you an overview, we are going to see a tree structure which will have branches. Each branch in a tree is labeled with a probability value, and the end of each branch marks the corresponding event or the outcome. Let's see an example. Suppose we want to visualize the result of two successive coin tosses. On each toss, there are obviously two possibilities, heads and tails. So the first of the two branches shows them. On top of the branch is the probability of the outcome, like I said earlier. So the probability of getting a head in the first toss is 1/2. And likewise, the probability of getting a tail is also 1/2. Now, next, again, for the second toss, there are two possibilities. So suppose we got a head the first time around, then getting another head, the probability of getting another head is still 1/2, and this is because these two are independent events. Similarly, the probability of getting a tail is still 1/2, even if we got a head the first time around. Now, if we go back to the end of the first toss and suppose we got a tails this time around, then we map our future probabilities again. So again, we have two possibilities. So the first possibility is that we get a head and the probability remains 1/2. And the second possibility, obviously, is that we get a tail and the probability of that is still 1/2. So for two coin tosses, that completes the probability tree. You can obviously imagine 3 coin tosses, and you can imagine that the tree will continue to grow with more branches. Now notice along all the second set of branches, the probabilities of heads or tails didn't change. And I mentioned it earlier as well. Now, why is this? Think back to dependent and independent events described in an earlier video. Pause if you need. Okay, so here's the answer. The probabilities of heads or tails don't change in the second draw because the two coin tosses are independent events, like I said earlier. And review the earlier video if you need to. So we can now write out all the possible events that can result after two coin tosses. So start from the top of the tree at the end of the top of the tree. So it could be a head and a head. It could be a head, then a tail. It could be a tail and then a head. And of course, it can be a tail and a tail. Now, because the two coin tosses are independent events, we can compute the respective probabilities of these events by multiplying the probabilities along the path that leads to them. On the top of the slide, I've put back the formula from a video on independent events. So if E1 and E2 are two independent events and E1 happens and then E2 happens, then the joint probability, we call it joint probability, is the product of their individual probabilities as well. So to work out the probability of the first event, which is a head, then a head, we work out the product of two probabilities along the path. So I just highlight that path for you. The path just blinked. So probability of getting head and a head is equal to the two probabilities on that path, which were 1/2 and 1/2. And that equals 1/4. Similarly, look at the second event. It is a head and a tail. So probability of getting a head and then a tail, again, we will multiply the probabilities along its path. And I'm going to highlight that path for you. So I just, that blinked. So it still works out to be 1/4. Similarly, the probability of tail then head, which is the third event, the probability is still 1/4, and again I'll highlight the path leading to that end result. And finally the last, which is probabilities of tail and tail, is again 1/4. So again the probabilities multiply along the way. Now suppose we want to find out what is the probability of finding a single head and a single tail across two tosses. Remember, the order doesn't matter. We just want to find one head and one tail across the two tosses. So what is the probability? Now, I hope you agree that there are two ways this can happen. A head, then a tail, or a tail, then a head. So both those events represent our event of interest, which is one head and one tail. So therefore, the probability is actually sum of those two probabilities. So we add the probabilities of those two events. So therefore, we add 1/4 plus 1/4, and the answer turns out to be 1/2. You can pause the video and work it out yourselves. Okay, so then here's another example. So in this case, we are going to work with dependent events, unlike the last one where there were independent events. So here's a bag that contains 7 red counters and 5 white counters. And the question asks you to use a tree diagram to calculate the probability that when 2 counters are drawn without replacement. Remember, once we draw a counter out, we don't put it back into the bag. Then what is the probability that both turn out to be red, both turn out to be white, or one of each color comes out? So note, in this case, the probability of second result depends upon the first result. Again, this depends upon the video on dependent events, and if you have not seen that, please watch it again. So remember from the video on dependent events that the probability of seeing event E1 and then E2 equals probability of E1 times the conditional probability of E2. That is E2 given that E1 has already occurred. So I've written this formula at the top of the slide for you. Now since there are 7 reds out of a total of 12, the probability of getting reds the first time around is 7/12, while the probability of getting a white first time around is 5/12. Now suppose a red ball has been picked in the first draw, okay, and we are not going to replace the red ball back into the bag. So this decreases the red balls to 6, and the total count also decreases to 11. So the probability of red second time round, given that the red was already picked, equals 6/11. However, the probability that a white ball is picked after picking a red last time is 5/11. And this is because all 5 whites are still available to pick from the 11 remaining balls. Now consider the other possibility, that in the first draw we picked a white. So that leaves 4 whites and 7 reds still in the bag out of a total of 11. Therefore, the probability of picking a red given that a white was picked earlier is 7/11, while probability of picking a white after a white is 4/11. Now we can also work out the probabilities of the twin events. So the probability of getting a red after a red is the product of probabilities along the way to this result. So you can pause the video if you want to map out the ways, but I'm just going to print it out for you. So the probability of getting red and another red, you just go along the tree. So this is 7/12 times 6/11. Similarly, the probability of getting a red then a white is 7/12 times 5/11, then white then red is given on your screens, and white is also on your screen. So you can pause the video and work out and verify these answers yourself, that they're true. And if you have any questions, please leave it in the comments below. And thank you very much. I'll see you next video.